Okay, so we left off. The class was having a discussion, and I'm not sure what happened, so I apologize, but the video had stopped recording. So we were talking about everyone came up with some form of triangle that looked like this in the class, and the only things that were different were sometimes they were turned or flipped or whatever, depending on how you started your ray, where you started your ray, and then which the longer side or the shorter side, if you put it on the original ray or on that new ray that you found. So depending on how you constructed it. However, if we all cut out our triangles in class, they would all lay right on top of each other. You just might have to turn or flip your triangle in order for it to make the pile all look like one triangle. So what we were able to decide is that if we have a side angle and another side, and we did a demonstration also using the same type of things that we used before. Okay, if I have two sides and I make an included angle, so let's say it has to have these two sides and this specific angle. It doesn't matter if you put it this way or you put it this way. Either way, all 3 points of the triangle are already determined from that angle and these two sides. So that third side of the triangle has to be there. You can visualize that right now. And it doesn't matter if I turn or flip it, that triangle doesn't change. Okay? And because of that, the side angle side postulate does work. This is a shortcut that does work. So if two sides and the included angle, included means that the angle has to be between the two sides. So notice our angle here had to touch both sides. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So in this case, what we noticed was we had an angle that was touching both sides. Okay? So when we write our shortcut, we want to make sure the A is touching both S's. Okay, so side angle side. This one's also labeled side angle side. Since they're both labeled side angle side, and that shortcut does work, we can then conclude that the triangles are congruent. Again, just like we did in 5.1 and on the other one, you have to be careful. You have to say that angle A has to match with angle D. And then we went to B, so you go from the one arc through the one dash. So from the one arc through the one dash, so the next letter has to be E. B has to match with E. And then the last letter would have to be F. So you just have to be careful when you go to name that. On this diagram here, what we showed was any sides that are marked the same length. Now remember, in order to put a congruent mark there, you have to be able to state because. So I marked this side and this side congruent because they're both marked as 60 inches. I marked this side and this side congruent because they're both marked as 48 inches. I marked this side congruent to itself with the 3 dashes there because it is a shared side. So remember, you have to be able to state the because in order to make the mark. Don't mark it unless you know a because. If you mark it without knowing a because, what happens is that means you're assuming something, and we don't want you to assume in geometry. Bad things happen when you assume. So, looking at this top triangle, we have 3 sides that are marked. The only way to rate that is side, side, side. Looking at the bottom triangle, you have 3 sides that are marked. The only way to write that is side, side, side. Since both triangles are marked with a shortcut that work, we can come up with a congruent statement. Write the first statement first, triangle ABC. Doesn't matter how you name the first triangle. What matters is how you name it. Then you have to make sure that A to B to C goes through the one dash, through the double dash, through the double dash. So when we name the other one, we're going to go through the single dash, through the double dash. We have to start at A, then go to D, and then go to C. So ADC would be how we name that second one. All right, so then we have the next one. So this one you're going to use some prior knowledge on. I tried to draw it so you could see. The first thing we marked was the shared side. Okay. The next thing that we had marked was, they had already marked this for us here. So the third thing that we had to find was they told us that these 2 lines are parallel. So I tried to highlight the parallel lines and the transversal so that way you could see them. Then what I did was I showed the class how 2 lines and a transversal look if we remove them from this image. So if we're looking at this, maybe I'll put here, easier to see. Okay, so two lines in a transversal. And we learned that corresponding angles were congruent, or alternate interior angles are congruent, so on and so forth. And so what I can do now is I can take and say, okay, these two angles are congruent because of vertical angles, which were congruent to these ones down here because of corresponding angles. I also knew that these ones were congruent because of vertical angles, which correspond to these ones down here. And by doing that, what we did was we slid this back onto our diagram and said, okay, then what angles do I have that I could actually mark? Notice this angle here doesn't really mean anything, okay, because it's not part of our diagram. So we then are only looking at this portion here. We don't have this labeled because it's part of this whole angle. So that is not an arc that we can consider. But the arcs that we can consider are these double arcs here and the double arc here. So I copied them onto my diagram. And then I said, okay, well, what type of angles are those? Those are alternate interior angles. Remember the zigzag. If you can make the zigzag, they're alternate interior angles. And our theorem states that if you have parallel lines, then alternate interior angles are congruent. So that's why I was allowed to mark that, because we learned the AIA theorem. Okay, so I was able to mark that. So now that I have three things labeled, I look at this top triangle, I have three things labeled. I have two sides and an angle. Now, there is a way that you have to write this, because the angle is touching, it's in between both sides. So the A has to be written in between both S's, okay? It's not on the end, it's in between them. The same goes when you look at this triangle here. Single dash to double dash, the angle's between them. So a side, and an angle. However, that angle has to be between the two sides. Since they're both labeled as side, angle, side, I can mark the triangles congruent. So I looked and I said, okay, mark the first triangle. I covered this up, named it however you want, triangle MON. That's how I named it. And then I said MON. It went through the double dash and through the no dash. So when I come this way, I have to go through the double dash, through the no dash. So I have to go OMP in order for it to be named correctly, because order matters. Okay? So hopefully that will help you on those with those couple examples.